This video is going to set out some of the basics of the decimal system. It's just good to watch as a starter if you're reviewing your decimal skills. The first thing we're going to start with is remembering that all the numbers that we ever write are written with only 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Each of these is a different shaped mark we make on paper that represents a number. Most of us are pretty familiar with those counting basic numbers up to 10, well, up to 9. And in this video we'll show you why and how it works to count up to 10, and we'll do more than that. So even though we're using only 10 digits, we can count up to numbers higher than the number 9 because we have a system which uses place value to add information to each digit, and it's based on its location. So here I have in the middle, this will be my ones place, this column. So I'm counting, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 that all will land in the ones place. And once I get one beyond 9, then I start using the place to the left of it, the tens place. And so here I have 10. Then I would have 11 and 12 and so on. Most people are familiar with this. So we'll jump ahead. Rather than counting one by one up to 100, the place, once you run out of space and you get to 99, use the tens and ones place. The next is your hundreds place. Hundreds. And then 10 times bigger than that. Once you have 10 hundreds, we're talking about thousands. I usually start off this discussion in my classroom by showing a set of numbers similar to this and asking which number would you rather have if I was going to give you cash. Most people immediately know they would rather have $3,000 than 330 or 3. We have in our brains, because we work with those like ones, tens, hundreds, and thousands on a regular basis, we're pretty confident with understanding which of those are bigger than the next. What we're looking at today is starting to understand the numbers that are, the places that are to the right of the ones place, the decimals, so-called decimals. So this number system, the ones place is basically the middle. Anything to the left of the ones place is getting 10 times bigger, 10 times bigger, 10 times bigger. Anything to the right of the ones place is getting smaller and 10 times smaller. And the marker that we have to show that is the decimal point. The decimal point it's like a piece of math grammar. It always appears to the right of the ones or the units place. The ones are the center of the number system, and the decimal point helps us find out where we are. When we use these zeros in the number 3000, 0 has no value. Its only purpose is to show me that this 3 is not a ones, a tens, or a hundreds, but it's a thousands. Those zeros are placeholders, and they're important ones, because if I owed you $3,000 and tried to give you 30, you'd be pretty upset. So now we'll take a quick look at how you write numbers to the right, the numbers that land in the decimal places to the right of the ones place. And that will wrap it up. And in the next video, we'll really start working with understanding what the decimals mean. So if you have 3 whole ones, if you take that and divide it by 10, if you make it 10 times smaller, then we're talking about tenths. And all of the decimal places on the right-hand side of the decimal point will have THS on the end of it to show that they are representing a fractional value. So these are tenths. Each one is 1/10. And if I'm taking the same digit and making it 10 times smaller, I now have 3/10. I can go again and have now 3/100. And these words mirror each other on either side of the ones place. So tens, tenths, hundreds, hundredths, the only difference being the ending. And then my final one for the purpose of this example, thousandths. So 3/1000. And just for a little thinker of a question before we end this video, we might wonder how many times smaller than 3,000 is 3/1000ths. You pause and think about that for a second. As I move from place to place, I'm getting 10 times smaller. So 10, 100, 1,000, 10,000, 100,000, 1,000,000. So this number is 1,000,000 times smaller than this one. Thanks for watching.